Built in 2016, this is the first industrial-sized biogas plant for the treatment of fecal sludge in West Africa. The plant is designed to treat 400 tons of fecal sludge per day, covering for about 1/4 of the city of Ouagadougou. As a first step, fecal sludge is delivered to the site by vacuum trucks. The weight of each truck is taken at the weight bridge. The sludge is then discharged into a feeding channel. Non-organic garbage is removed and the liquid flows into a reception pond. 100 tons of concentrated fecal sludge are separated from the rest and used for the biogas process. The remaining 300 tons of diluted sludge are redirected to a classic wastewater treatment plant, combining sand filters, drying beds, and open lagoons. For 3 days, the substrate undergoes hydrolysis and acidification, the first 2 steps of anaerobic digestion. Before the substrate enters the main digester, it is pasteurized at 70 degrees Celsius for at least 1 hour, killing all pathogens and making sure the digestate is safe to use as a fertilizer. As the fecal sludge is mostly composed of water, co-substrates are added to increase the biogas yield. The biogas plant is able to receive nearly all types of organic waste and turn it into clean energy. Depending on the type of co-substrate, the material needs to be pre-treated, crushed, mixed, and pasteurized. The heart of the plant is the main digester, a continuous steered tank reactor with a volume of 2,500 cubic meters. Every day, fresh substrate is fed into the tank, while the same amount of digestate overflows into a buffer tank. Next, a solid liquid separator extracts a dry, high-quality fertilizer, which can be used by local farmers. The remaining liquid is pumped into a second digester with a membrane gas storage, which produces further biogas from yet undigested substrate. About 3,000 cubic meters of biogas per day are produced around the clock, 365 days per year. It contains around 65% methane and is used to fuel 2 combined heat and power generators. The gas is stored in a 1,500 cubic meter double membrane gas holder until it is consumed. Before the gas is burned, traces of water and hydrogen sulfur are removed by compression and active carbon filters. A 100 kilowatt CHP provides electricity for autoconsumption. Pumps, stirrers, and other machines can all be operated without an external source of energy. A 1 megawatt CHP is connected to the national electricity grid and provides around 7,000 kilowatt hours per day to households and local businesses. The excess heat is stored in the form of hot water and used for the heating of the pasteurization tank and main digester through a closed system of heat exchangers. The entire plant is operated and monitored from the control room. Each machine can be remote controlled from here and be fully automated. Through tight surveillance of the key process parameters, the plant operators ensure a safe and efficient running of the biogas plant. New substrates are tested for their biogas potential in the on-site laboratory, while regular tests of the input materials ensure the quality of the substrate. This biogas plant is a pilot project to show the benefits and the enormous potential of anaerobic digestion as a treatment of fecal sludge in Burkina Faso and all of West Africa.